Okay, so I'm going to go and take a look at 2.1 transformations in the plane and just kind of orient you to the whole top section of this and just make you all feel real comfortable with what it's saying. So when you need to go back and take a look, you'll have a good way to reference it. All right. So the top is just talking about the fact that we're going to be making transformations of different shapes. And we've already started to see how translations in the next section uh, are just the movement of our shape around the plane. And so the plane in this case is the coordinate plane. A plane in any situation would just be like a piece of paper, for example. And if you think about a plane bisecting something, imagine if you could just like take a piece of paper and run it through something with like a knife. That would be a plane bisecting something. So you'll see that idea come up later. But anyway, we're just transforming shapes. It's talking about transformation F. Ah, it's all such gobbledygook, but what it's basically telling you is that transformation F is this stretch factor of 2, and when we look at this guy, there it is. You see how that triangle has been stretched by a factor of 2 to the right. So, cool. There's lots of different kinds of transformations, and we're going to take a look at a couple different kinds of transformations down here. So we're going to recognize rigid transformations. So a rigid transformation means that the shape has stayed the same. Anytime you see the words rigid transformation, it means the length has stayed the same. Okay? Looking at this top one, we can see it's not, right? It's not a rigid transformation because the lengths here, A to C, and A prime to C prime, those are definitely not the same. The length has not been preserved between the two triangles, all right? And if you need to prove it, go ahead and take those points, take point 1, 3, and take point 3, 1, throw them into your distance formula, take A prime, which is, what is that, 2, comma 3, and then take C prime, which is 6, comma negative 2, and we'll see those kind of show up down here, all right? And those are the other points up there. And you throw them into your distance formula, and you see where you get, all right? 2 root 5 and 4 root 2. And what we really care about, because we don't really know what the simplified radical form is yet, most likely. If you've seen it before, fantastic. But we really just care about square root of 32, square root of 20. We can very easily see that that is not equal, right? If you see the simplified radical form, basically that just means 2 times the square root of 5, all right? And that is exactly the same thing as root 20, or the square root of 20. I'll explain that to you all much later. So anyway, you also have another transformation that is a reflection, all right? So you can sort of see how this triangle K, has reflected across line segment or line AB, all right? And it's created triangle K prime. So there's another transformation. And you can see that that one's definitely a rigid transformation because the distances have been preserved, all right? They've been preserved between those two triangles, so we have what's called a rigid transformation. And then, and if you haven't gone on to 2-2 yet or haven't looked at that yet, that's where we're going. Translations, all right? A translation is literally just like the shifting, like a pawn moving across a chessboard or any piece on a chessboard, kind of translating across. It hasn't changed. The shape of the pawn isn't any different, all right? It has just moved across the plane, and so just like this, it has followed a vector, v, and it has translated this triangle K across vector v to make triangle K prime. Oh goodness, across vector v, what does that even mean? Okay, all that is talking about is using the slope of vector v, which is up 2 over 1, all right? Up 2 over 1. We're going to do that to every single point. Up 2 over 1. Up. Where is it? There it is. 1, 2 over 1. Up 2 over 1. There it is. And so that's translating it across a vector, along a vector. That's awesome. Great. We've done it, all right? And so that's called a translation. There are other transformations, but that gives you the idea. This is just the changing of an original shape, the pre-image, into the new thing, the transformation, which we call just the image, all right? Have a good one. Hopefully this helps orient yourself to the information that's here. Go ahead and do the practice, and I hope that this helps.